Iteration can be used to solve equations. The first step is to rearrange our function into the form where it's x equals. So we make an x equal to some function of x. There are different ways of doing this, and some iterations will work. They will converge to give us a root. Others will not work, they will diverge. So here we've got 3 different ways, there may be more, of rearranging this function so it is x equals. So it's f of x equals 0. So we're starting with x squared minus 8x minus 1 equals 0. The first one, we want to get x equal to x squared minus 1 all over 8. So if we just plus the 8x to both sides, and then divide by 8, we get x squared minus 1 over 8. The second one, we've got a square root in it. So let's get x squared by itself, and then square root both sides. So plus 8x and plus 1 to both sides, and then square root. And the last one, we want to divide by x minus 8. So let's get the 1 by itself. So plus 1 to both sides, x squared minus 8x equals 1. Then factorize out the x. So x times x minus 8 equals 1. Divide both sides by x minus 8. We get x equals 1 over x minus 8. Here's an iteration question. We've got a function, x squared minus 3x plus 1. And we need to rearrange to get it x equals 3 minus 1 over x. So we're going to get x squared by itself. So plus 3x and take away 1 from both sides. And then divide through each term by x. So x equals 3 minus 1 over x. So now we're going to turn this into an iteration formula. So we're going to have x n plus 1 equals 3 minus 1 over x n. And we're going to start with x0, our first one, as 2. So we're going to substitute in 2 first into our function. So that's going to go in here. So if xn, if n is 0, this one will be x1, 0 plus 1. So our x1 is going to be equal to 3 minus 1 over 2. So we're going to substitute 2 in. That's the first one we're going to substitute in. Then we're going to get out an answer, which is 3 minus a half, which is 2.5. Then we're going to substitute in our next answer. So substitute in 2.5. Now that's going to go in, and that's going to give us x2. So x2 is going to be 3 minus 1 over 2.5. And I'll use the calculator. What we can do with these iteration questions is if we press 2 equals, that was our x0. So get that as our answer. And then just set it up. So 3 minus 1 over answer. So 3 minus 1 over 2 was 2.5. That's x1. Press equals again. x2 is 2.6. And then we'll substitute in the 2.6. So just press equals again. And we get x3 is 2.615. One for you to try. See if you can give it a go. So we've got f of x is x cubed minus 3x squared minus 5. We need to show that the equation f of x equals 0 can be written as x equals the cube root of 3x squared plus 5. So we just get x cubed by itself by adding 3x squared and 5 onto both sides. So we started with x cubed minus 3x squared minus 5 equals 0, plus the 3x squared plus the 5, and then cube root. So then this becomes our iteration formula. So we're substituting in to the right side to our function of x. We're starting with 3. So x0 is 3, so x1 is going to be the cube root of 3 times 3 squared plus 5. So that'll be our x1. So we'll just type that into the calculator. I'll press 3 equals, so I can use my answer button, and then cube root 3 times answer squared plus 5. So we're putting 3 in to our iteration formula. We get out 3.17. So x1 is 3.17, and so on. So 48, I'll give 4 decimal places. x2, so we put 3.1748 in there. So that's going to be the answer button. Press equals again. 3.2785. 3.2785. And x3, so we're putting in, substituting in to our iteration formula, 3.2785. So press equals again. 3.3396. So they are our answers. And the idea is each of these answers gets closer and closer to the actual solution. So if we keep pressing equals, eventually it will stop changing, and that will be our root. So the actual root is getting closer and closer to is 3.426. When we look at this on a diagram, we can see why it works. So we've got another function, x squared minus x minus 3. Show that it can be rearranged to give x equals x minus 3. So just add x to both sides, and we get x equals x squared minus 3. So then this becomes our iteration formula. So we have x on one side and a function of x on the other side. And this is drawn on the graph. So we've got y equals x, which is our blue line, and we've got y equals x squared minus 3, which is our green line. And they're both drawn on the diagram. Use the graph with x0 as 1.5 to explain whether the iteration will converge or diverge. So when we have an iteration formula, we put our starting value, so our x0 is 1.5, we put it into our function of x, which is our green graph. So we're going to put 1.5 as our x, 1.5 is our input, and it goes into our green graph, and we get out an answer. This answer will be negative 0.8, and we want to put that back in for x again. So on the graph, we can use our y equals x to change our output, which was our negative 0.8, into an input. So then that goes in for x again. If we put that value of x into our green graph, negative 0.8 goes into our green graph. What do we get out? We get out negative 2.5. Then we're going to put that into our green graph again. So we use the line y equals x to kind of bounce it back. So it was a y. It was y equals negative 2.5. and we're going to put it in for x. So now it's x is negative 2.5. That goes into our green graph. We get out an output, which is 3.2, roughly. Now we want to put that in for x. So we bounce it off of our line y equals x. So it was an output. That's now our input. We're putting 3.2 into our green graph. And we can see we're not getting closer to a root. We're getting further away. So it will diverge. Here's another one. And it's actually the same starting equation, same function. X squared plus x minus 3. But this time, we're going to rearrange it to give x equals 3 over x plus 1. So we're going to have x squared plus x minus 3 equals 0. We're going to get 3 by itself. So x squared plus x equals 3. Factorize out the x. And then divide by x plus 1. And then we're going to look at this one on the graph. So we're starting with x0 is 4. So we put it into our function of x, which is this part, which is our green line. So we're going to put in 4 into our green line. And we get out something around 0.6. We want to put that into our green line. So we bounce it off of the line y equals x. And we get something around 1.8. We now want to put that in to our green line. So we bounce it off. And we get out something just over 1.1. Now we want to put that in. So bounce it off of the blue line, the line y equals x. We get another output. We want to put that in. So bounce it off. And so on. And we get closer and closer. We are converging. So this one converges to a root. And we can see the root is where the intersection is, which is at around 1.3.